All right, lesson 8.2, we are going to be graphing ax squared plus c. So what we're going to be doing, it's kind of, we started last lesson with f of x is equal to ax squared. So if you think about this, ax squared plus bx plus c. The part, so we're missing the middle part. We have ax squared and c, okay? So what this is going to do and how this is going to transform our parabola, our parent function, so to speak, is it's really just going to shift it up and down on the plane, all right? And in this case, the vertex of the origin of this graph, f of x, ax squared plus c, is the vertex is at 0, c, and the axis of symmetry is equal to 0. So the parent function has a vertex of 0, 0, and then if c is greater than 0, it would shift up, okay, from 0, 0. If c is less than 0, it will slide or shift down. So it translates up and down. Everything else about it is the same. I know when you kind of look at this, believe it or not, if we pulled the red one over the parent function or pulled the green one down over the parent function, everything would line up. It's just the way that the parabolas work and how they, keep getting wider and wider that make it look like they're not exactly the same, right? But it's the shifting that changes it. Okay. So everything else about them would remain the same, unless it's a vertical stretch or shrink, which could happen too. All right. So looking at the example from your textbook, here we have x squared minus 2. Remember, the parent function is x squared. So make your table of values, plot the ordered pairs, draw your smooth curve, then compare them. So the blue one is our g of x, the f of x is our parent function. So you can see that the g of x is below the parent function. So we'll describe it. So they both open up, they both have the same axis of symmetry. The vertex of the graph of g is 0, negative 2. It's below the graph of f, which is the vertex is 0, 0, because the graph of g is a vertical translation 2 units down. So these might be the types of words and things that I'll be filling in the blanks on big ideas. So let's go ahead and graph. So we want to start with the table of values. Okay, so again, it's easiest if we make about 5 points to graph. It makes it get the curve a little bit easier. So we want to take negative 2 squared, which is 4, plus 5, and we get 9. Negative 1 squared plus 5 is 6. 0 plus 5 is 5. And you can see that this is where it's crossing the y-axis. It's our y-intercept. Then we'll have 1 plus 5, and then we'll have 4 plus 5 again. So I'm going to go ahead and let's just count by ones, make it a little easier. Draw on our coordinate plane here. And then we'll plot it. So negative 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6. 0, 5. And then it's pretty symmetrical here. Go ahead and graph it. Okay. This would be our parent function. Okay, 0, 0. So when we look at this and compare it to the parent function, we know that they both open up. They both have the same axis of symmetry, which is x is equal to 0. And then g of x is translation five units above f of x, I guess, or the vertex of f of x. All right. So make sure that you're able to describe that. Well, let's try another. Now we got a little bit more going on here. This time the coefficient of x is not a 1, but the coefficient of our parent function is still 1. So we'll make our table of values. Again, we can -2, -1, 0, 1, and 2. So when we take -2 squared, we have 4 times -3, which would be -12 minus 2. So we get -14. And then 1, -3, so we have -5. Here, if we have 0, we would get -2. And then this should all work out the same. All right, this time I'm going to, so we're going to be graphing maybe in the third and fourth quadrants of the coordinate plane. So I'm going to move my x-axis to the top. All right. So -2 and -14. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, woo, off the grid. -1 and 1, 2, 3, 4, 5. 1 and -5. I didn't do 0 and -2. Got to do 0 and -2. All right. Oops. 1, -5, and 2, -14. So we're going to have all right. All right. So now because we did it this way, let me change colors here. Our parent function is still right here, okay? So when we're looking at comparing these, we have some things that have changed now. This looks narrower, right? And we have this to think. It's opening down, and that's because of the negative number. So n of x is a vertical stretch by a factor of 3. Let's see, is a reflection in the x-axis, and the vertex is translated to units down of f of x or the parent function. Okay, so make sure that you can explain all of that. All right, so now we're going to solve some real-life problems here. In this problem, first thing we want to talk about is the zero of a function. A zero of a function f is an x value for which f of x is equal to 0. So now the output value would be 0. Just like when we solved the trinomial equations where we made them equal to 0 so that we could solve for the variable, there might be some factoring that we need to do. A zero of function is an x-intercept of the graph of the function. So this is a place where y is equal to 0. It's crossing the x-axis as well. So in this function, it looks like you can see you have a person that's dropping something. Okay, it's represented, the function -16t squared plus s sub 0 represents the initial height in feet of a falling object t seconds after it's dropped from the initial height of this s sub 0 in feet. So we have an egg is dropped from the height of 64 feet. So the s sub 0. So f of t is equal to -16t squared plus 64. All right. So we want to know how many seconds does it take for the egg to hit the ground. So we want to factor this. So the first thing we're going to look for is a common factor. when I'm solving for part A, I see, so f of x, so we'll have 0 is equal to, because we want to make the height 0, and we would factor out a -1. Well, we could factor out more than that, can't we? We could factor out a -4, actually. So if we factor out a -4, we're going to be left with 4t squared minus 16. Okay, this is a difference of 2 squares. So we will have 2t plus 4 and 2t minus 4, because this is a special pattern. Now, this example isn't in your student journal. It's in the textbook, but I just thought it'd be better if I explained it before we do any word problems down the road or solving for these zeros. So now we need to solve for t to find our time. And we know that this -4, there's no variable here. So we just divide both sides by -4 and it's gone. So we know that we have basically 2t plus 4 equal to 0, or 2t minus 4 equal to 0. So you're subtracting 4 from both sides. 2t is equal to -4 divided by 2. So we have this t is equal to -2, or we have plus 4 on both sides. T is equal to 2. Since what we're finding is the seconds, this is kind of erroneous. It doesn't really make sense. So it basically takes 2 seconds before it hits the ground. Okay, that would be the height of 0. So if we took a look at what the graph would look like right here, all right, it's really only half the parabola that we're talking about, because this would be the initial height of 64. You can kind of read that on the y-axis. So this is our 64. It's going to fall down like this, and when it hits the ground, it will intersect with the 2 on the x-axis. Okay, you could graph it as well to see for that to work out. Okay, so now suppose the initial height is adjusted by k feet. How will this affect it? Well, think about this. If we take this initial height 64 and we add to it, right? Let's add to it, whatever it might be, add k, right? It doesn't matter. We shift it up, right? What that's going to do is kind of bring that parabola. I could try to like follow, and it will intersect here. So it would take longer to fall. If we adjusted k, right? So if k is, I want to say that greater than 64, or k is positive, right? It would take longer. If it's less, oh boy, I'm not good with these. It would take shorter amount of time. So it's going to change the time in seconds is what it's going to do, and that's how it will affect it. So basically, this one represents k being greater than 0. If it's a positive number, we're going to add to the 64, and then it'll take longer than 2 seconds. And here, this is what happens if k is less than 0, and we subtract from 64. Okay, and it's going to change the projectile of the object and the amount of time it takes for it to hit the ground. All right, so keeping in mind all that, let's find the zeros. So now this is just very much like what we did in our last lesson. The zeros of the function means we're going to make y equal to 0. So we will have 0 is equal to -x squared plus 1. So first thing I want to do, factor out a -1. I'm left with x squared minus 1. Difference of 2 squares pattern. X plus 1, x minus 1. Therefore, I have x is equal to, we'd be subtracting 1 on both sides, or we'd be adding 1 on both sides. So I should have, not that, I should have an equal sign here. All right, so it's equal to -1 or +1. Why don't you go ahead and do number 6. Please find the zeros of the function. I'm going to move over to number 7. First, I'm going to make it 0 equal to -x squared plus 64, common factor, -1. X squared minus 64, difference of two squares. It's all equal to 0. So that means that we have x is equal to -8 or x is equal to 8. Okay, and go ahead and do number 8. So we have to do 2 problems on this page. All right. So then we'll do this together. So here's your function, -16t squared plus s sub 0 again. This is similar to that example 4 we looked at in the book. I don't know if it was example 4. Whatever it was from the textbook with the building and the egg. We have a falling object. So it's the height in feet, that's the output. T seconds after it stopped from an initial height, s sub 0. It's a tennis ball falls from a height of 400 feet. S sub 0 would be equal to 400 feet. So we would have f of t is equal to -16 t squared plus 400. So we want to check to see is 400 divided by 16? Probably. So let's factor that out. So we have 0 because that would be what the height is. We can factor out a -16. We're left with 425 minus 25. So then we have 0 equals -16, and we have t plus 5, t minus 5. So t is equal to -5, or t is equal to 5. And in this case, we're talking seconds. So 5 seconds is how long it would take it to hit the ground. Suppose the initial height decreases, right? Decreases by 384 feet. So we are subtracting 384 from 400. Okay. And so what do we think? Is it going to be faster or slower? Well, let's find out. So our function changes. We have f of t is equal to -16 squared plus 16. So we'll make our 0. We'll factor out our 16. This is not like that. I hate when I do things like that. 16 t squared. Okay, so we're left with t squared minus 1. So we have 0 is equal to -16, and we have t plus 1, t minus 1. Remember, this is a difference of two squares. So then we have t is equal to -1, or t is equal to 1. Negative seconds has no meaning, so it is obviously a shorter amount of time before it hits the ground. Be sure to let me know if you have any questions.